This is the stainless steel pilot that's been configured for the HCL trial. It's the 1000 CFM pilot. I've added a clear plastic spool piece in here that came from the old plastic pilot unit. It's configured with a ductwork system that leaves from the top of the scrubber. I had to put a spiral wound pipe because the suction that can be created was collapsing the real light gauge ducting. Transitions into the PB12A blower, and then discharge duct that goes up. Currently, I just put this up in the exhaust system for the room. I'm getting a cap there to be able to seal that when we actually run the trials. The blower is a 230 volt blower. I wired it into the outlet in the back there on the wall. I have an extension cord arrangement. The gas inlet is just open right now. I'm going to be installing a duct on there by the time Howard Hesketh comes here, so we can put in the HCL. There's a gauge panel here that I'm setting up for to measure the pressure drops, various stages from the first grid on up. It's just basically a one grid unit. It has a flanged grid in the center with a swirl inducer in the center, and the pump in the back here is from the trial that was done up in Wisconsin. So that March magnetic drive pump. There's a rotometer. There's a hose connection in the back to the sump, a hose connection up to this horizontal header. There's a sight port here, so you can look in and see the grid. There's the header. It's kind of hard to see. He's probably trying to focus on the glass. The header's in there. I'll turn this on in a few minutes. And there's a conventional droplet eliminator. Rather than remove the header, I just put a valve there on the upper header. The header physically is in there, just that there's obviously nothing going into it. And I have a backlighting system I'll turn on in a little bit here that will backlight it so you'll be able to see the fluidized zone. This is the arrangement with the fluorescent light in the back. I purchased the drop light a while ago to be able to see things around here. So there's a fluorescent light there, and I have a light up above that's shining in through one of the sight ports so I can observe the bottom of the chevron while the unit's in operation. I've turned on the pump, and you can see the rotometer right there, King Instruments rotometer. I'm using that to regulate the flow, to measure the flow actually. I'm regulating it with a valve. There's a valve both on the pump and also on the header up here. And right now you can see that valve is wide open. The pump valve is about half closed. It's about a 10 gallon a minute to 15 gallon a minute liquid flow rate. The water's coming in the header. And if you can see that, you can see how the water comes in kind of on an angle. Just an open pipe header. There's nothing really special about that header. And of course there's no airflow, so therefore there's no pressure drop really on here. The water cascades down through the inlet. You can probably hear it more than see it, but it just cascades down into the sump. I'll move the drop light over, and then you can see the water just cascading down as it normally would without any airflow. This is I'm shining the light inside the inlet. You can see the water coming down. It mostly comes down the center when you don't have any airflow on. It just cascades down into the sump. I'll turn on the fan now, and you'll be able to see what happens. Okay, this is the unit without the blower on. I'll go turn the blower on here, and you'll be able to see the